Okay, my goal here is to help you connect two concepts which hopefully you're familiar with, and make a little bit more sense of what is sometimes referred to as trigonometric ratios, but actually most people know it as SOHCAHTOA. Okay, and one of the most important things about SOHCAHTOA is you can only use it when you have a right angle triangle. So you have to have a little bit of a right angle right here. And then you can use these trig ratios. Okay, so let's start by reminding ourselves a little bit about slope. So slope is a concept which helps us understand about lines. So I'm just going to draw a nice line here. Oops, line like that. Okay, and then I'm going to give myself a bit of a coordinate system. So here's a y-axis, okay, and here's an x-axis. Excellent. Okay, now what I want to point out to you is slope. Let's see. Let's go back to this. Slope measures steepness. Steepness. So the thing about a line is that the steepness never changes anywhere on the line. That's pretty much the definition of a line. So slope measures steepness, and the steepness is the same everywhere on the line. The same everywhere. This is not true for a curve, and that would actually sort of also be the definition of a curve. So I just show you that here. So the steepness is the same everywhere on a line. So if you can imagine that you have to maybe ride your bike up this, it's sort of just unrelenting steepness. Oh, oh, oh. Never gets easier and never really gets harder. Whereas if you have a curve, then it's like, oh my goodness, I cannot possibly make that. Oh wait, maybe I can, because look, after it curves off and actually it starts going down. So here the slope is changing, the steepness. This is called a curve. This yellow line here, straight line, means that the slope never changes. Let's take everybody off here. Okay, so what this means for us is that if we want to measure the slope of this line, it doesn't matter where we go on the line. Okay, so we just pick two completely random points. Of course, if we're just at one point, we're just standing here on our bike, then we're not really experiencing the steepness. We have to move from one point to another. That's when we notice how difficult it is. So the way we can measure the difficulty or the steepness of the line is by comparing the rise and the run. Okay, so here, this is not too bad to ride your bike up this line, because say this is a 1 meter here, so in order to gain 1 meter in height, you're going to move, say, 1, 2, 3. Looks like this is 3. Okay, so you get sort of 3 whole meters to get up that 1 meter. So our slope is equal to rise over run. Remember, it compares these two quantities. So it's equal to 1 over 3. Okay, and you might notice something right here about this rise and run line that I put in here, is that surely they are at 90 degrees, because straight up and straight over are at 90 degrees. And if I were to sort of fill in from this point to this point, you can see we have a little triangle here. Exactly the kind of triangle that we use SOHCAHTOA in. Okay, because in order to use SOHCAHTOA, it has to be a right angle triangle. So only for right angle triangles. Right angle. Here we'll use a bit of abbreviation. Right angle triangles, right? Or sometimes I just draw a little triangle that has a right angle in the corner. Okay, so that doesn't look like a right angle. It looks like an acute angle, but anyway. Okay, so back over here. So slope measures steepness. The steepness is everywhere the same on a line. So a line, steepness never changes. So what if I wanted to compare, instead of this point and this point, what if I wanted to compare, say, this point and this point? So that means my run would be, wow, I'd be going all the way from here over here. So I'd have this whole horizontal distance to get up that amount. So now it looks like, okay, you have to forgive me here. Let's just say this is 6, so this is almost twice as far, and we get up twice as far. So this is now 2. So you see when we make the comparison, the slope is equal to a rise. Well, we went up 2, but we got a whole 6 meters across to do it. So it wasn't any more difficult as the same slope as the other 2 points. So rise over run staying fixed here. So now, in order to link this into the SOHCAHTOA, let's go back and remember that with SOHCAHTOA, what it's telling us is that if we pick an angle, say let's pick this angle right here, then what we need to do is label the sides of our triangle. So the one opposite the 90 is always the longest, and it's called the hypotenuse. The one opposite the angle that we're working with is called the opposite, so this is opposite. And then the leftover one, which will be sort of beside our angle, is called adjacent. Okay, and SOHCAHTOA says stuff like, well, let's look at TUA because that's the one we're really thinking about right now. TUA means that if you take the tan of this angle here, it gives you the ratio of the opposite over the adjacent. Okay. Now, this angle right here is a feature of this triangle, right? And these kind of triangles, these right angle triangles, show up on lines when we draw in the rise and the run. So then we get a little right angle triangle like that. And with this yellow line, this big one here, will create a triangle, and it would have an angle right here. Okay, this angle is sort of a measure of the space between these 2 lines. So the more this line rotates around, the bigger the angle. So let's see if it just rotated around more, then we'd be looking at a bigger angle, right? So it's a measure also of steepness. So angles measure steepness. Angles measure steepness. Okay, so slope is one way of measuring a steepness, and an angle is another way of measuring steepness. So there should be a relationship between them.